Alright, I will now give you a run through of the lab reports cards demo parts. I have accomplished doing this part by spending an extensive amount of time. So in the case that I can't present this in 5 minutes, I am hoping that dear TAs and our professor can watch this and award extra points. So here, as you can see, I set the FireProc exe here, and it's the Alubit. I click on write to FPGA here. I've already clicked on that, so I do not want to click on it again. So here we have the cards, which is perfectly working. Let me get it back to its original position. So right now, as you can see, everything is set to as zeros. I will now tell you how I mapped the ports now. So as you can see, this one here is S9. S9 is S1. S8 is S0. This one is A0, A1, A2, A3, B0, B1, B2, B3. So I have arranged it such that if I click on P32, it will switch to arithmetic mode. Otherwise, it will stay on logic mode. On P37, P37 is the C in, is also C0 on the lab manual. P77 will light up if overflow or underflow is occurring. P89 will light up, P89 here, this will light up if this is a carry out, if this has a carry out bit, if the output of the arithmetic part has a carry out bit. So I went over the mappings. Let's go, and I will give you a demo. So by default we are set 0 0, so this is by default doing AND operation between these 4 bits and these 4 bits. So let's set the first bit of A to 1 and set the second bit of B to 1. As you can see, this lights up. The reason why that LAD light up is because I mapped these as the outputs. So this is output 0, output 1, output 2, and output 3. As you can see, if I keep on turning these on, it will the lights will light up one by one, and this is due to the AND operation. I am doing AND operation between this one and this one, this one and this one, this one and this one. That is the reason. So same case. So after you figure this out, it's much easier because I will now do the XOR operation. So for the XOR, let's do the OR operation. So for the OR operation, we set this to 1 because S0 has to be 1, S1 has to be 0, and as you can see, regardless, 1 or 0 gives out 1 or 0 gives out 1. I am turning these off one by one. As you can see, it worked perfectly. And now I will do the XOR operation. I will turn this off and turn this on. So now I'm doing XOR. So if I turn this up, it will light up because XOR lights up when the inputs are different. As you can see, as long as they are different, they will light up and turn off. So XNOR is a bit different. It's the opposite of XOR. So I will turn these off one by one. If they are the same, it lights up. If they are not the same, turns off. The same case here. So as you can see, when I'm playing with this, so it's so much fun. Yes. Right now I am done with the logic unit parts. Let's switch to arithmetic unit parts. So let's start with arithmetic unit part. We are going to get A first. So by default A is 0. I mean, I can increase A 1 3 7 1. So this is a good example because this is -1, right? A equals -1 when all of the bits that describe A is turned on. As you can see, this LED turns on because I mapped this LED as the negative sign. So if this is a -1, this one lights up and this one lights up. Okay, this is really important. Otherwise, and let me show you that that I do not show B. So regardless, even if I play with B, it doesn't move up or anything. So let's see if C in C out is working. So I will now click on both of these at the same time. So as you can see, when I click on these at the same time, 0 is displayed. It's kind of hard actually to give out 0, but as you can see, this is 4 is displayed. Can I zoom in? I mean, yeah. So yeah, you can see that 4 is being displayed right now. Anyways, so you can see that 2 is being displayed here. When I click on both, you can see that 1. So by default, this is 0. I click on both, it displays 1. So I hope that I was able to show at least arithmetic unit 0. So now I will sum up A and B. For summing up A and B, S0 has to be set to 1. This one. Alright, so let me show you the results from the original lab report, because I think this will help me convey myself better and also double check if there are any issues. So I will actually set this to unsigned decimal. I will set this to signed decimal. I will set this to signed decimal again. So on this part, I will show you the demo. So as you can see, if we so these two are the results from the first two operations. This one is A plus B. So -7 plus 6, what does it give? -1, right? And this is what I'm getting, -1. F3 is -1. So here I will, I mean, there are a bunch of things which are related to the board here. This is not running, I mean, I synthesized the ALU.bit on here, therefore this is the reason why you're seeing unrelated stuff there. As you can see, the result has to be 1, right? So let's set it up. A has to be like this, B has to be like this. Right now, okay, so as you can see, this is -1. This is perfect. So 0, 1, 1, 0, 1, 0, 0, 1. What happens when you sum them up? Gives you -1. So this is the negative sign, this is the 1 sign. I'm getting the correct results. And again, in order to show that the C-in works, I will click on this, and you can see that I'm getting a 0. I'm getting a 0 with a carry out. Let's see if that is correct on the results, and it is correct. So as you can see, when I do the C in, C out, it has to be C out gives out as 1. All right. So now that we have figured that one as well, let's switch to the other one. The other one is where we do the, let's see, from the lab reports, A plus B negation. A plus B negation. All right, let's do that. So for A plus B negation, we have to turn S1 up, and we have to turn this one down, and then we have to click on this one. So we're getting minus, what are we, is this minus? No, we're getting a 2. We're getting a 2 with a carry out, and we're also having an overflow case. Well, let's go and see if this is correct. All right, this is correct. This is really, wow, this is correct. All right, so we are getting a 2 with an overflow. You can see it here. You're getting a 2 with an overflow. V stands for the overflow. C out stands for the carry out, and so forth. I will now do the same thing with the carry in. We are getting a tree, obviously, and oops, we're getting a tree. How do I actually show this? We're getting a 3 here. As you can see, this is a tree, and everything lights up perfectly. I will now go to here and I'll show this to you. So yep, as you can see, they are working. This is the desired output. The last 2 cases. Alright, we're about to be done here. And the last 2 cases are A negation and plus B. A negation plus B works when S1 and S2 are set to 1. So I'm setting both of them to 1 now. And now I'm going to click on this thing, and it yields a 4 with a with an underflow, I believe, and P93 lights up, so it's a sine LED, so it's -4. I will show to you through this one as well. So as you can see here, -4 for -4 here. We have an overflow case. We have a sine bit lighting up. It's a -4, and it's really happy. I feel really happy that this thing worked. All right, so on -3, let's see if this will work for -3. Oh, all right. So here I'm click on this now. This guy right there. Okay, so this is -4 turns into -3 on this mode when these are turned on, which is what I was expecting. It's all correct. All right, thank you for listening to me.